Welcome to another Advanced Manufacturing Media webinar. Today we're covering one of the hottest topics in manufacturing, the smart factory. Specifically, we will ask the question, is your factory smart enough? Beckhoff and Intel will help provide the answer. Hello, I'm Jim Sawyer, Executive Editor of Manufacturing Engineering Magazine, which is part of SME's Advanced Manufacturing Media. Beckhoff, if you weren't aware, implements open automation systems based on PC control technology. They offer a broad product range that can be used as separate components or integrated into a complete and seamless control system well suited to many industries. Our other sponsor, Intel, is more than just a chip maker. It also supplies leading-edge computing solutions to industrial customers. This extensive experience gives Intel a unique perspective on industry trends, needs, and wants. Our subject experts are Damon Thompson, Automation Specialist, Beckhoff North America, and Rama Karamsetti, Intel's Segment Marketing Manager, Industrial and Energy Solutions Division of the Internet of Things Group. Damon acts as technical liaison and represents the Beckhoff software product management and development teams in North America, focusing on the advanced automation and control software, TwinCat 3, among other duties. Rama is responsible for customer business processes, marketing, executing new products and technologies, executing solution strategy, and enabling end-user pull for Intel technology in the power and automation industries. During the presentation, you will be able to ask questions using the Q&A box that appears on the right side of your screen. Time permitting, your questions will be answered following the presentation. If time runs out before we can get to all the questions, we will make sure the answers are emailed to you. Now, we are able to go as much as 30 minutes past the top of the hour. If we do, we hope you can remain with us. If you can't, you will receive an email later telling you how you can view the entire presentation. And if you experience any audio or visual difficulty during the live presentation, please let us know via the Q&A app. Also, if you have questions about any other aspects of our webinars, please email me at jsawyer@sme.org. So, let's begin. Rama, please tell us what we'll be covering today.
Thanks, Jim. Hi, my name is Rama Karamsetti, and I'll be going over basically a few topics at a very high level. I'll be talking about IoT. I'll be talking about the trends in industrial automation and what do those trends mean in terms of economic impact. I'll be sharing some of the key tenets that Intel sees are important for IoT solutions. And then I'm going to share a high-level use case as to what it means and how it leads into smart manufacturing. And at the end of it, just going to leave it a little open-ended and ask you guys to figure out, okay, where do you fit? And thereon, we'll have Damon pick up and talk about specific solutions through our partnerships here. So let's begin with a simple definition of Internet of Things. Right? So what do they mean? I mean, things that are connected, that integrate greater compute capabilities, and use data analytics to extract meaningful information so that anybody or everybody can make better decisions. Okay. So, what does that mean, or why is it important, right? I mean, most of you have probably seen this data of 50 billion devices connected in the next 10 to 15 years, 44 zettabytes of data, and how are they going to be connected through the sensors, right? But what you may not know is that 85% of the devices deployed today, that means about 15 billion, by the way, are not connected, presenting not only a huge opportunity to connect the unconnected, but to deploy new intelligent devices. Okay. To add to this, the significant trends we see in economics of technology over the past 10 years is helping go through this path. The cost of sensors has been down 2x. Okay. The cost of bandwidth has gone down 40 times. Okay. And the cost of computing itself has gone down 60x in the past 10 years. So what do these reductions mean, right? I mean, in combination, this creates an opportunity for an inflection point to connect the unconnected, proliferate computing from the devices to the cloud and across cost-effective networks. All in all, these trends are going to unleash a lot of IoT opportunity, impacting the way we work and also the way we live. Okay. So that's the big picture of what IoT brings to the table. So what does it really mean when it comes to manufacturing or industrial automation? So here are some of the key trends we've been seeing as an industrial leader here. Okay. The worldwide consumption has been doubling, and it will double in the next decade also. It drives the need for efficiency in operations and processes. Manufacturing productivity is increasing, but it needs to accelerate. So since the recession and the global financial crisis, I mean, we've seen some increase in the productivity, but when you look at the increase in productivity and compare it to the increase in demand, we're not able to keep up. In order to keep up with the demand, the productivity needs to double in the next decade. There needs to be technology to help with this. Okay. The only way we can get more efficient, more productive, and get more things with not much increase in resources is technology. Rising labor costs is the other factor. Okay. To add to the rising labor costs, like we discussed in the previous file there's a decrease in the technology cost, and there's a humongous increase in the improvements that the technology is bringing. This is revolutionizing robotics. So this means cheap labor geos or low-cost labor geos are a thing of the past. So what used to be very lucrative in terms of the developing nations using their workforce might not work in favor of manufacturing going forward. The ROI on robotics and automation is increasing along with the cost of technology coming down. We believe this is going to be a very interesting space over the next few years. Just because now you're at an inflection point where your robotics could probably be more effective and more cost effective than going into low cost geos. On top of this, functional safety mandates driving requirements in the new industrial products. These are the methods to improve on the safety of humans on the factory floor as well as assets from all the new applications and machines that are going onto the factory floor. The next trend we are seeing, or we all know, is convergence of machine-to-machine big data analytics, and which is causing cyber physical systems to come into play. All are leading to newer opportunities on the factory floor for all of us. And the last trend we see is the geopolitical investments to ensure competitiveness. So many of us have heard of Industry 4.0, but this has been predominantly a German and European initiative. So to counter it or to ensure competitiveness, US and China are looking for technology to help with Industry 4.0, or China calls it 2025, US has a different name. But what does that all mean, right? This is good for us as it helps us with accelerating the technology adoption, which generally doesn't happen at a very fast pace in the industrial and manufacturing sector. So we are just, this kind of, all these kind of give a nudge to the slow-moving end customers. So we've seen the trends, and we understand there's this huge IoT influence. So what does it mean in terms of our own? What does it mean in terms of our own industry, right? What does it mean in industrial and energy, right? So there's at least $6 trillion of opportunity in IoT applications by 2025. This is a third-party market report provided by McKinsey, and what it shows is that manufacturing, energy, infrastructure, and security represent 55% of this $3 to $6 trillion of economic impact. So that means if we can go in and focus on industrial and energy use cases, we're going to get a lot of this economic impact, and we'll be able to address the market needs and be able to get to this $3 trillion of opportunity. So there's a lot of low-hanging fruit in these industries to increase efficiencies in factories or the electric grid or in the oil and gas industry by just connecting devices and analyzing data to run the operation more efficiently. So by just capturing the value of these low-hanging fruits, we'd be able to achieve the $3.1 trillion. So the $3.1 trillion, if you look at it, is a big number, right? And there's a lot of work that needs to happen to capture this economic impact. So Intel, along with partners like Beckhoff, is working towards creating solutions that can capture this economic impact. So one key area both of us as partners are focusing on is smart manufacturing. Okay. So when we say smart manufacturing, what does it mean, or how do we want to go with it? Are we just jumping into this, right? So to address that, Intel has created what we call as the fundamental tenets of any IoT solution. These scale across all segments or markets out there that are relevant to IoT, but they are even more prevalent in industrial and manufacturing segments. So Intel basically defined 5 tenets that define an Industry 4.0 IoT platform. These tenets represent the principles or guidelines we use to shape our long-term IoT leadership strategy. They also represent what capabilities we build in the future in partnership with ecosystem and partners like Beckhoff. Okay. So let's go through what these tenets are, right? So security should be a fundamental need from sensor to cloud. No question on that, right? We'll have to make all our hardware as well as software assets fully interoperable and secure. It helps deploying millions of endpoints easier for our immediate customers and end users to enable faster path to smart manufacturing. Okay. The next tenet, there's a critical need to connect, discover, provision, and manage devices at scale. There should be an ability to set up in a few minutes and an ability to be discovered in a few seconds. If we can get that, we'll be able to adopt and capture these low-hanging fruits that we are talking about. There's also a need for data normalization due to the disparate data types so that we can run analytics and change data to information. So provision for seamless data ingestion, we need to have real-time capabilities and closed-loop control capabilities. And then we must be interoperable with a broad set of open protocols. Okay. So the fourth tenet here is analytics itself, right? So analytics capability must reside not just at the edge or in the cloud, but it should be use case dependent. Okay, so the analytics should be able to provide insight into the value that Industry 4.0 can provide end users. Lastly, and the last tenet we are focusing on is the desire to expose the info to developers who can manage and monetize the information to create value and create added services. So we want to be an enabler for the entire ecosystem to be able to extract value from our products as well as our partner products in both hardware and software and derive value from services provided on top of them. So we're looking to build open, scalable, industry standard protocols and architectural designs, and that's how we can make this possible. So now that we know the key tenets that Intel's focused on, what does it lead to, or can we actually talk about a simple use case, right? So we have seen the value of IoT, the economic impact, the trends, and the tenets we are working towards. So how does it impact manufacturing, or what does it mean to the terms like Industry 4.0 or smart manufacturing, right? So there's many ways in which Industry 4.0 can help benefit all of us. Okay? It can optimize timely delivery of materials from supply chain or provide consistent quality of products to customers. Okay? So in between, we do have our manufacturing processes that need to be made more efficient too. Okay? So on the supply chain side, timely just-in-time delivery, right, of raw materials can be made possible, and streamlined logistics from order to raw materials is possible because of Industry 4.0 or IoT. So what does this do? This creates value to the customers. They receive consistent quality of products. They have the ability to have responsive customizations to the orders, and they have the ability to see and have timely delivery of alerts and updates. Okay. So let's look at one example. How does it work, or where does it work? So within the factory itself, let's look at using predictive maintenance and how it helps with maintaining uptime, right? So a factory can instrument its tools and connect them to the factory data center. We can now perform analytic functions on vibration, temperature, pressure, or you name it, any sensor data, and be able to predict when maintenance is needed. So how does it help, or what does it mean to the manufacturing facility, right? It lowers the maintenance cost by reducing the preventative maintenance tasks, as some of these tasks or activities can be eliminated. It also reduces downtime in the equipment by avoiding sudden issues and having an early warning or early active warning system. Okay. So in summary, accelerating edge to cloud can help all stakeholders in the value chain. Many areas can be instrumented. Interruption of service can be avoided and obviously is not acceptable in many manufacturing facilities. So being able to extract intelligence in the infrastructure requires straightforward installation and should be easily bolted on existing infrastructure. So that's how we feel that Industry 4.0 or China 2025 smart manufacturing can be implemented. So on top of this, Damon's going to come in and talk a little more in detail as to how this can be achieved with some products and ideas. Okay. So that said, I just want to come up with this last slide here, right? Just to provide some thoughts. Okay. So where do you want to focus on? Do you want to focus on increasing automation? Do you want to focus on flexible manufacturing? Or do you want to focus on factory digitization? Or do you want to focus on big data? Or do you want to focus on mobility and wireless, right? So you could pick any or all of these areas and lead to in Industry 4.0 or smart manufacturing facility. Okay. So that said, I'm going to hand it over to Damon to take over the presentation and continue in detail as to what Industry 4.0 is and how is it that Intel and Beckhoff can help you go this path. Damon?
Thanks, Rama. So my name is Damon Thompson with Beckhoff Automation, and we're going to cover kind of a list of the stuff that Rama mentioned earlier. For some reason the slide's not coming in. So we're going to look at kind of this automation convergence that allows us to take the automation space, the machine control, traditional PLC, and really tie it into these IT technologies and these IoT technologies. Look a little bit about IoT and how that fits in with Industry 4.0 and kind of that definition of some of the things that Rama was touching on. The smart factory, a little view into what does that look like, and from an architecture standpoint, what does it look like? Some of the smart factory technologies and tools that Beckhoff's offering and what's happening in that space. Talk about a live demo. We can look at some data being pushed through, and then an actual customer case study. So we'll get started looking through some of those things. So a little intro to Beckhoff. Beckhoff's a machine controls supplier. We provide servo motors to I/O, field bus, to controllers, and they're PC-based controllers powered by Intel chipsets. The industrial IoT is really easily integrated into industrial PC-based controllers as opposed to a lot of traditional PLCs. And many customers have already used Beckhoff controllers for integrating data communication with databases or to the cloud and remote maintenance over the internet or tying to cloud-based services. A little bit of overview on how did we get to where we're at. So this is kind of a timeline history. So somewhere in the 80s, the automation space was using a lot of smaller processors, proprietary processors, building their own hardware. And in that same time frame, Beckhoff looked at it and said, well, Intel's doing some really fantastic development, really driving technology forward with chipsets. How can we harness that power of the processor and make it deterministic and put it in a machine controller? And that was kind of the beginning of the PC-based control. Somewhere in the 96, 90s range, there was a lot of talk in the automation space about real-time operating systems and making it deterministic. And we decided, well, in that same space on the IT side, there's this Windows embedded, and how do we combine those two things, again, to make PC-based control, but make it very hardened real-time and it run on a PC, and that's where our TwinCAT automation software was born. Somewhere in the early 2000s, there's a lot of stuff with field buses and making deterministic field bus with things like Profinet and DeviceNet. But we really wanted to look at how do we take the idea again from the IT side and combine them with networking, with the TCP/IP or with Ethernet. In that time, it was really an explosion of the connectivity inside your house. People were putting home routers in for the first time ever. So those combinations gave us this Ethernet or EtherCAT, which is a Ethernet field bus that's very deterministic. So somewhere in the 2010 range, we took our TwinCAT automation software, combined it with Microsoft Visual Studio, which is the #1 code editing software in the world, and added a lot of other new functionality, created TwinCAT 3. So that brings us to kind of today, where there are a lot of standalone automation technologies, still a lot of special proprietary communication protocols being used in the IT space, but they're starting to be combined with the IT space of big data and getting data to the cloud and using analytics. But already on the PC-based control side, we really already have this architecture that's the smart factory that really allows these technologies to be taken advantage of really quite quickly. So if we look at the factory itself, there's always challenges that kind of every manufacturing facility is looking at. Everybody wants faster delivery and a bigger mix of lots of products, better product traceability, flexible lines, smaller machines, etc. These are definitely challenges, like I said, that are kind of universal. And making changes to these things and solving these problems or optimizing some of these problems definitely comes back to needing data. And getting that data means connecting the IT world and the MRP system, ERP system, MES with your machine controls, really getting the data from the production. So this becomes even more complex and even more of a problem when we start looking at this in a global standpoint. Whether you have a disconnect between your different manufacturing facilities or a disconnect through your supply chain. If you're not getting the data from these operations, it makes it really hard to make changes. You can't see the production status, the current status. We can't really measure performance well, and we can't improve the execution. Or we can't make good value decisions based on anything. So that kind of is where some of the IoT idea comes in. So let's look at the IoT and break it down into kind of its simplest form. So we start with the things. These are the devices, and in some cases these are our industrial things. These are our robots, our PLCs, our machine controls. Those have a connectivity, whatever connectivity it may be, whether it's a wireless connectivity, a cell modem, whatever it is. That connectivity is used to push data, and that data needs to have some analytics run on it. And the analytics that helps drive insight that perhaps makes either better things, figure out how customers are using those devices or those machines, or help optimize the performance of those existing machines. So the industrial Internet of Things. So it really is taking this idea and these technologies that are emerging, whether it be mobile, whether it be IoT protocols, whether it be data analytics, and really applying those to the industrial setting to make optimizations to those settings. And this is really being driven by this convergence between the automation technology and the IT technology really coming together. And in a lot of cases, we see that there's actually a marrying of the automation controls department with the IT department because they're being converged such closely. So these things being put into the industrial side really is going to create a new revolution in what we see in industry. And that revolution is kind of been defined by this Industry 4.0. And it's defined as the first one as a steam engine. It really changed the way manufacturing works really forever forward. The next one came along with kind of the industrialization of conveyor belts and assembly lines. And again, really changed the way we thought about manufacturing and the way we optimized manufacturing processes. The next one that came that we can all agree was a huge revolution in industry was the kind of the modernization or the implementation of PLCs and microcontrollers. It forever changed the way manufacturing worked. And in the same way, the cyber-physical systems or the application of IoT principles, these things are going to, again, forever change the way we look at manufacturing. No longer do we have a big piece of iron that's chugging away at a process. For forevermore, we'll have that big piece of iron chugging away at a process, pulling data back, figuring out what it's doing, why it's doing it, and optimizing its process. So looking at a smart factory, even in a global enterprise. So it's kind of an overview of an architecture. Definitely, the machine control, PC-based machine control with some sort of field bus, gathering all of the information from whatever sensors, doing some condition monitoring on that sensoring, so checking for vibration or looking at different temperatures or seeing if there's trends in those vibrations or the temperatures. Those machines talking to other machines, the end-to-end communication, to be able to do things like flexible manufacturing, to let the machine downstream know which product is coming kind of real time. That data then being pushed up back to an MES or ERP system, and even pushing that data even farther to a location like cloud-based services so that your other manufacturing facilities that are located across the world can be sharing that data back and forth, or all the data being pushed back doing analytics to figure out, perhaps why is one manufacturing facility putting out more production than another. And those things maybe looking over global energy usage, something of that nature. So cloud-based is definitely something that's starting to be seen more and more in manufacturing. It was definitely used more in the IT space for kind of reducing capital investments and being able to use infrastructure as a service or a software as a service that's been hosted on the internet somewhere and just utilizing those services. Small companies would put the email on a cloud, and that's been happening for a while. On the industrial side, there's definitely more usage for utilizing some of those services. And some of those use cases are remote monitoring of the machines, so having a machine be able to push a notification out to get the appropriate personnel notified that either the machine is down or the machine is low on material. So the application that I like to use is a packaging machine that perhaps has a roll of film, and that roll of film gets low. You can have the machine push notifications to devices that everybody's carrying these days, push the notification out to a cell phone, to a smartwatch, and let the operators know or let some of the supervisors know that somebody needs to get to that machine and attend to that roll of film before that roll of film runs out and we have downtime. So we can very quickly exchange that before it's needed. Or do more stuff like data acquisition and analytics, kind of in a neutral location for energy management, material data, kind of collective. And same thing with pulling the data acquisition and storage up is doing some analytics for predictive maintenance and things like machine learning for catching things before the machine's down. So Beckhoff's really introduced and announced a suite of tools that are built into our TwinCAT automation software that's going to help really help the implementation and make this simpler for the machine builders or for the end users who like to get that first step into the IoT integration. So some of these things that we've built in are integration of standard protocols that are really used in the IoT space, like MQTT and AMQP and things like OPC UA. Things like a data agent that allows it very simply to configure which data from the PLC you would like to send to a central repository or up to the cloud, and at what interval. And then every, whatever it is, 3 seconds, it's pulling that data up and pushing it into, say, a Microsoft Azure SQL database at a given rate with very little programming, more configuration. Or the IoT Communicator and IoT Communicator app for doing a scenario like I talked about previously, where the machine from PLC code can fire off a notification, and that event notification gets sent to a mobile phone and even pull up an app that shows a small history of the notifications that have come from the machine. And that connectivity and having that data is really good, but of course having the data is not enough. We need to make really good decisions based on that data, and that's going to take data analytics. So also, being built into this TwinCAT suite is analytics software, so we can push the data up, take a look at it for things like cycle time and in analyzing, maybe why does the cycle time vary on this machine, or analytics based on sensor data and vibration to look at preventive maintenance, things like that. Make actionable information. So one of these protocols that I mentioned was OPC UA, and it's a vendor-independent protocol, and it's a protocol that Beckhoff really backs and really supports, and it's really flexible, and the main thing is for interoperability. So with a protocol like OPC UA, we can talk not only from the controller to cloud or controller to the MES system or ERP system, but from controller to controller, helping integrate the machine-to-machine communications in the smart factory. So while a factory, most factories we'd love to have, the majority of the controllers be Beckhoff controls. That's not always the case. And so we need to integrate with some of the other machines for things like lot size one manufacturing and flexible manufacturing for sharing production information or recipe data between the controllers. The other thing that as Rama mentioned, the first consideration in all of this is security. So security is kind of built into this OPC protocol, and it kind of security from the sensor to cloud. And that's something that really important when doing this implementation. And it's not a Beckhoff protocol. It's not specific to the automation space. This is really a industry and domain independent for interoperability. So that's one of the protocols that we really back that you'll see when we talk about flexible manufacturing in automation space. So cloud connectivity, just to give a couple of examples over the next couple slides here on ways of implementing this. So we talked about OPC UA as a protocol, so I'll start with that first. So this is the first way is being able to push it directly from the machine control, from the PLC program, securely encrypted, and push that up to a cloud-based service that has an OPC UA client or server, or potentially even running a virtual machine in the cloud, running something like TwinCAT with the OPC UA server, pushing data up to that, and then moving that data over to a cloud-based database to capture the data. Even using a Beckhoff protocol ADS directly from the controller to the cloud, or just directly from the controller using the TwinCAT database server, pushing it directly from PLC code into a SQL Azure control, really minimizing the amount of hardware and software layers in the middle, direct database connectivity to the cloud. So some of these other protocols or alternatives that are definitely known from the IoT space and the mobile space, but becoming more known in the industrial side, is things like AMQP and MQTT, but more specifically using things like brokers, message brokers. So the idea with a message broker is that both devices on either side, whether it be machine to machine or machine to some mobile device, both of these devices can push data as outgoing messages into a queue, into this broker, and then be pushed to the other side. And to establish these connections, they're all outgoing communications. So the outgoing communications makes it really nice for the IT side and the security side, meaning that you don't have to open up incoming firewall ports or do incoming port forwarding to have the data be passed from one device to another. So these AMQP and MQTT, these are, again, protocols you'll see from used in Amazon Web Services, Microsoft Azure. They're standard protocols, very high performance, very lightweight. The big thing with the message brokers, again, is the message brokers don't need internal firewall ports turned on. And the message brokers as well doesn't necessarily have to be something that leaves the enterprise or has to go through a cloud-based service. You can implement an MQTT broker within your own enterprise for communications and not necessarily have to leave the enterprise network. Here's kind of an example of so some of these things tied together. So having the data is really great, but we also need to do some analytics on it. So this is an example of the PC-based control system running the line, and machine 1, machine 2, machine whatever through an existing machine, pushing that data up to the central repository either within the enterprise or cloud-based, utilizing something like web-based services, Microsoft Azure, Amazon Web Services. And then through IoT communications, being able to use an analytics software, something like TwinCAT Analytics Server, to do some predictive maintenance, looking at it, look for trends in data, look at trends in the cycle counters and energy usage, and just analytics on whatever you're focusing on. So in that factory, as another example here, in that factory we want all the machines, regardless of what controller they're running or whether it's a big controller or a small controller. Some of the bigger controllers running these really great Intel-based processors can definitely do some of this analytics on the fly, kind of the edge-based computing. They can do some of it there. Or even some of the smaller ones that don't have the capabilities of doing the analytics right on them, we can push the data into either a local cloud or, again, a remote cloud. A local cloud within that factory, once that data is there, be able to store the data and then run analytics on it, looking for some of these things for predictive maintenance and different efficiencies. And if it's in a scenario where there's multiple factories, then again that data can be pushed to a central cloud-based service and the storage be made there or the analytics be made there. And there's a couple of use cases here. So the end users running a manufacturing facility, they definitely want to make optimizations to their existing line. But the OEM has some interest in some of this information as well. So we have a use case where a machine supplier, an OEM, allows the machines to be pushed, data to be pushed from these machines from anywhere in the world. So if the end user of these machines wants to participate in the program, they hook the machine up, allowing it to have an outgoing connection. And as these machines run, it pushes all the data back to a central location that is kind of housed by the machine builder, by the OEM. The OEM, the machine builder, looks at this data and says, okay, what's the #1 alarm all of my machines have? What's the #1 product size that these machines are running? What's the average cycle time? What's the high cycle time and the low cycle time? And they use some of these analytics to say, well, if 80% of my customers are all running this small size product, maybe I can offer a machine in the future that is focused on those sizes and not have to make it such a big footprint. I can optimize my machine design. And in the same token, they can offer a service to these end users that says, hey, as we're monitoring the machine, we know the machine better than anyone. We built and designed the machine. So we'll give you some feedback about how we see your machine running. And if we detect a problem ahead of time, we can let you know before the machine fails. Like, hey, we've noticed that we're not quite running inside this parameters on this motor. There seems to be some extra drag mechanically. I think you should check that out. And the OEM can offer that as a service. And then, of course, once we have the data from any of these areas, the data stored can be used with a third-party analyst, a third-party software to, again, look for other anomalies and other conditions within the data. So here's the same kind of idea overview, but looking at this message broker architecture in the middle. So a smart factory running multiple controllers, multiple machines, pushing data either to another smart factory, so doing notifications within the supply chain. Both facilities, located geographically independent, but one facility happens to go down, they ran out of material or had a machine failure, and they can automatically notify the line in the second one that says, hey, we need to run more of a certain product because this one's not going to get run today, and automatically ramp up through a central location using something like this message broker, again, with outgoing messages to establish the connections. And that data in the middle could be pushed up for analytics or analytics with other tool sets. So another example of architecture, this is a demo that we've done at some trade shows, and in fact after the webinar you can take a look at the iotdemo.beckhoff.com URL. There's 3 pages I believe there. They're different trade show demos. The first one, the IoT connectivity demo, we've kind of powered up. This demo is a wall with some of our Intel-based PC controls, and it's actually sitting in Germany at our corporate headquarters. And it'll show you some different analytics or different data, live data being streamed from it for CPU temperature and CPU usage, things like that. And like I said, we powered up one of those at 1 out of the 3 demos at this time, so take a look at the IoT communications demo on that page. But the architecture for those, it's, again, on the left-hand side of the slide here, a PC-based control from Beckhoff, powered by an Intel chipset, running the TwinCAT Automation software. We're pushing the data up to Microsoft Azure through Stream Analytics. The Stream Analytics can look for high points, low points in the data, and kind of log those anomalies off through a service bus and a web app, and then pushing that data out to a website, to a URL to see the live data. Another demo that we've done at a couple of trade shows is we had a 6-axis Stabile robot talking the EtherCAT Automation protocol to our controller. Again, this is a quad-core i7 Intel processor. We pushed that data up to Azure using the OPC UA protocol with encryption. And then within there, we used Signal-R protocol to push that data out to mobile devices. And it made for a really nice demo. As customers came to our booth, we could scan in a QR code, get them access to it, and actually interface with the demo kind of live from any device. Here's another overview of architecture. So the controller's down at the bottom, and these controllers can be multiple machines within the same facility, or each one of these little bubbles can represent a manufacturing facility, kind of firewalled from the internet. Data from them being pushed up through the internet, maybe using the AMQP protocol, again, possibly through a service like Microsoft Azure Stream Analytics, looking for different high points and low points in the data, logging those things off to SQL Azure as a historian, maybe using something like Power BI or some other way of visualizing that data across the enterprise, and even using that data for anomalies to do push notifications to some wearable devices. So now I want to talk about an application we did with a customer. The customer's Nobilia. This customer builds kitchens, custom manufactured kitchens, something like what's in this picture. They've been a long-time Beckhoff employee, and they've really embraced, Beckhoff customer, and they've really embraced the Industry 4.0 practices and really implemented it. So there's, within the facility, all the data is tied together with an Oracle database. There's 540 Beckhoff PCs in this facility, and they've really taken this lot size one. So if you think about this kitchen, everything within this kitchen can be customized. Which handles do these cabinets have on them? Do they have handles or pull knobs? Do they have corners that are radius, or are they squares? Are they have beveled edges? So every one of these is kind of custom. So what happens in their facility is the material comes in with a barcode on it. The barcode gets read, and it kind of cues the facility and says, okay, my next operation that this needs to go through needs this certain size hole drilled in certain locations. So it queries the machines and says, who's available to do this? And the machine will say, I have availability and I can do that operation. And the material gets pushed through the facility, routed over to the equipment, processed, and then again scanned and says, the next operation that I need is this, and which machine in the facility is able to do that, and it really gets routed through it. So if one of the machines is down or one of the lines is down, it really gets routed through without some manual intervention of having to move material around or stop the entire production line. It's really lot size one, really kind of what we call manufacturing by wire, and it's been extremely successful for them. They build about 2,600 full kitchens a day out of the facility there. So it's definitely been successful. So kind of as a little wrap up, there's a lot of these IoT and Industry 4.0 and a lot of these tools that are really available now, and there's a lot of things that can help to get companies started in this endeavor. We really feel, again, that the PC-based control architecture really offers a lot of advantages over some traditional PLCs, in being able to write directly to files or write directly from PLC to database and make that very costly. Being able to implement new IoT protocols and being able to connect and utilize new services. So standard PC-based hardware is definitely the best architecture for this. And we already have customers, as we've shown you, that are implementing these things and have been quite successful all around the world. So for more information, here's some contact info. Again, the web page demo is at iotdemo.beckhoff.com, and some other ways of contacting us here at Beckhoff. And with that, I would like to pass it back to Jim Sawyer with SME.
Thank you, Damon, and thank you and Rama for a very informative and thought-provoking session. I can tell you it is thought-provoking because we have received a lot of questions, and it would be nice to get to all of them before our time is up. I will remind you that we can go 30 minutes past the top of the hour. We will try not to go that far, and we hope that as many of you as possible can remain with us. So let's go to one of the really basic questions, and that is, all of this technology is interesting, but where can a company start in implementing these technologies?
Yeah, I can start with that one. So as Rama actually kind of pointed out on one of his slides, the first thing that I would recommend is, you got to kind of identify the business use case. So are we looking at reducing downtime for a machine? Are we looking at reducing maintenance cost, or shipping somebody remotely to do maintenance? Perhaps that means gathering the data and doing some good analysis about how often do I need to send a field service guy out to a remote location. And if I gather data on approximately when things fail, or I can see anomalies before they fail, then it saves having to send somebody out. Or are we focused on connecting the supply chain and making it flexible manufacturing? So first thing I think I would recommend is identifying the business case. Secondly is once we know kind of what we're going to go after, we need to start connecting the devices and gathering data from sensors. And that's the next kind of technological challenge, is look at what controllers are in place, what protocols are in place, and then what software or solutions do I need to apply to that to gather that data and put it in a central location. And then that's followed by the data analytics. What can I see from this data? What can I gather? How can I take this data and turn it into actionable information? And then from there, that's going to help drive insight on the business case that says, okay, now I can make actions against reducing this downtime or maintenance or connecting my supply chain. And then this kind of reiterates and continues this loop of continuous improvement. And I know Rama had a slide based on that. I'll also give him an opportunity to comment.
Damon, that's right. I'm trying to pull up that slide so that everybody here on the call can look at it. So I think you got it right, wherein this is on a case-by-case basis. I mean, where do you start depends on what your business use case is. Where do you start definitely depends on what kind of resources you have and what direction you want to take in the future. Okay, so like I said, if it's someone who's looking to improve their efficiency, you should probably look at just increasing automation and figuring out what is it that they can do to improve either asset or process, and then in the process optimize them. So when we look at it from the Intel standpoint, we look at all these use cases in IoT as four major buckets. So is it asset optimization? Is it process optimization? Is it factory or facility optimization? Or is it workforce optimization? Okay, and depending on where your focus area is or what your end need is, we'll go in and dial down and figure out what is it that you can do in each of these areas.
Very good. Here's a question that really is not one that will be answered today, but certainly is thought-provoking, and I will put it to both you gentlemen. What should the next educational system look like to support the workforce that is needed for 21st century Internet of Things?
And do you want me to take a stab at it first?
Yeah, take a shot at that, Rama, please.
Sure. So Jim, that's a great question, right? I mean, when we talk about smart manufacturing, Industry 4.0, all that we've been concentrating on all these years, or most companies have been concentrating on, is how do we improve process or efficiency, right? And like I mentioned in the previous chart here, so as Intel, we're trying to figure out what does it mean to go in and figure out workforce optimization. And part of that is you could probably be seeing an industry, there are many industries out there where the aging population will have to retire in the next 5 to 10 years. At the same time, the newer generations coming in won't probably have the time to ramp to the experience that these aging populations will be going out with. So how do you come up with that gap, or how do you fill that gap? And that's where, once again, technology comes into play, right? So will it be something like a smart wearable, or will it be something like a smart equipment that sits on the factory floor? That's something that's to be figured out. And once again, depending on where you fit or what kind of industry you're in, that can be different.
So things will evolve depending on circumstances.
So purely, yes.
All right. Here's another fairly fundamental question. PC-based, does that mean Windows-based?
I can take a stab at that one. Not necessarily. In our application with Beckhoff, we definitely have a good relationship with Microsoft, and we feel that the Windows operating system definitely offers a lot of advantages being on the controller. There's definitely a lot of HMI packages. There's a lot of software that's already out there that can run right along with the real-time system. And the real-time system really running in kernel, kind of isolated from the operating system, so that it's not really having any influence. So in our case, we really feel there's advantages there, but not necessarily in every case. There's definitely other PC-based controls that run another operating system that can take advantage of some of these advantages, some of these nice things, but the Windows operating system definitely has a good place, I believe.
And another question, what are the long-term benefits to enterprises that implement smart factory connectivity? Rama, I know you have to go in a few minutes, so why don't you take this one?
Sorry, Jim, can you please repeat that?
Sure. What are the long-term benefits of let me find it here again. Yes, what are the long-term benefits to enterprises that implement smart factory connectivity?
Oh, one obvious benefit is obviously, the efficiency, right? The productivity, it has to increase or will increase with IoT, right? So when we look at this, leads back to the trends. Okay, so we see a lot of demand out there in the world, and the production is not meeting the demand. Okay, so implementing IoT is going to help you get to the point and be able to monetize in the process. Okay, and on top of it, the way the industry is trending, so you might be seeing an issue today on your factory floor that is probably not going to be any relevant to an issue that comes 2 months or 3 months from now. So going the IoT route, you have all the information, and you can probably be either go and act retrospectively or be able to come up with models that are showing you, hey, within the last 4 months, I've seen failures in zone X, Y, and Z. So what does it mean? Does this mean that I'll be seeing a similar issue in zone A, B, and C, which are close to this or similar to this? So it's going to add a lot of value in terms of total operations as well as revenue impact.
Very good. Rama, thank you. I know you have to go. We appreciate your being here and sharing your expertise with us, and we will carry on with Damon from this point. Again, thank you, Rama. Our next question, will go to, not a problem. Our next question, which goes to Damon, what is the best way to handle changing security requirements within corporate networks?
Ooh, that is a good question. Security, basically, the number one step that takes with security is doing risk assessment. And based on that risk assessment, what kind of security infrastructure needs to be put in place. We're seeing a trend where a lot of people are moving some of these things to cloud-based infrastructure, simply because it's a medium-sized or even medium to large-sized companies that just doesn't have the resources to put a lot of security expertise within the enterprise. And these companies feel like if they can give encrypted data up to a cloud-based service, something like Microsoft Azure, that the data has more chance of security being put there, as there's kind of a larger security team in the background. And that just seems to be a trend that we're observing.
Okay, and here's another sort of security-oriented question. How warm have industrial customers been to cloud solutions versus on-premises products?
Yeah, so that's another good question. It's kind of interesting, actually. It seems to be broken down a little bit geographically. If you look at the U.S., there's been a decent adoption rate. There's definitely a better comfort level with cloud-based services. Anything that we're offering for Beckhoff specifically, we're really trying to give customers the option to say, in certain industries, the data has to stay within the enterprise network for security reasons, for privacy reasons, but definitely giving the option to utilize some of these cloud-based services or infrastructure as a service. But in other places of the world, some places in Europe, the adoption isn't really that great for cloud yet. People would prefer to load these things onto the localized network, and Microsoft's even supporting this same idea with allowing certain aspects of even the Azure services to be loaded and run on-premises servers. So it's a little bit mixed, and depending on what industry, like I said, it may be something because of privacy concerns that it may not ever possibly use cloud-based services, and so we make those services available to run on-premises servers.
Very good, thank you. Really changing gears here, but still staying on an important topic. How important is energy reduction in terms of IoT use in factories?
So like the previous question, ironically enough, within factories, it depends again, it seems to be more geographical. Within the Europe space, energy is a lot more expensive, and this becomes a different value proposition where even implementing some of these analytic software and the connected devices or connecting existing devices, that infrastructure and that amount of time and resources put into it, there's definitely a faster payback in monitoring how much energy is being used within the facility. This is becoming something more trendy in the U.S. As companies become kind of more environmentally conscious or better global member, global citizen, and as well as energy costs rise. But it definitely seems to be a little geographic at this point.
Okay, that makes sense. Given that most assets are based on proprietary controls such as FANUC, Siemens, and so forth, how does Beckhoff connect their PC-based systems to them?
Yeah, so when we're talking about other controllers, Beckhoff really, we try to pride ourselves on being extremely open. So multiple protocols, and in fact we support just over, I believe the number is just over 30 different field buses. So if we're talking to something like a FANUC control, it's something like EIP. If it's the Siemens control, it's going to be with Profinet. And really being able to tie into just about any sensor or control that's used in your application. A lot of those things, again, will come back to OPC UA as a protocol of choice as well because of the interoperability and being kind of vendor agnostic and adding security into it. So we can pull that data into a Beckhoff controller, do some condition monitoring with our condition monitoring libraries, and some analytics on the fly within the device, with the device with the Intel chipsets, or even utilizing that TwinCAT software running controller to utilize these IoT frameworks and push the data up to some other analytic software, or to storage, or to cloud-based storage, or whatever sort of services it needs communicated to.
All right. We'll take one more here. It appears that our audience has stayed with us for a long time, but they do seem to have other things to do. So we'll make this the last one. How does OPC UA stack up against MT Connect?
From my understanding, I'm definitely not an MT Connect expert, but MT Connect is very widely used in the machine tool industry, and it's definitely a way of packaging up the data and exchanging between machine tools. It's growing in other spaces, from my understanding, and if you look at OPC UA, it's a lot of the communication side, but it allows for vendor-specific protocols to write on top. So it can definitely be something where the OPC transport layers can have the MT Connect kind of packets within it and communicate between OPC UA client and server, but with MT Connect data. So I do know that those can write on top of each other, but we'll have to get back to you on a detail-by-detail specification breakout.
Right. Okay. Well, thank you, Damon. Thank you, Rama. This, again, is Jim Sawyer. If you have any questions for me, you may contact me at jsawyer@sme.org, and we will be providing your email addresses if your question was not answered to our friends from Intel and Beckhoff so they can get back to you with answers on those. The Society of Manufacturing Engineers and Manufacturing Media, as well as Intel and Beckhoff, have ways for you to keep in touch with the latest developments in manufacturing. For instance, this spring, the first issue of Smart Manufacturing magazine will be published, and that's its logo down there in the lower left-hand corner of the slide. The magazine will focus on new and emerging technologies that are coming into play as manufacturing dives deeper into its digital connected era. And a preview of Smart Manufacturing, as well as subscription information, may be found at www.sme.org/SMART. In addition, SME Events will have a full calendar of exhibitions in 2016 that will allow you to look at and learn about the latest in manufacturing techniques and technologies. The first of these is AeroDef, to be held February 8th through 11th in Long Beach, California. Thanks for joining us for this Advanced Manufacturing Media webinar. We hope you found it informative.